this video about understanding of aging and measurements of aging, of the biological age. I will go in details. I hope you watched this summary before with a short introduction to the presentation, but now we'll go to more in details. So please mind to download the presentation as PDF file from the link in the description. You can go to the sources of information. You can do your own research, and I remind you that I'm not medical professional. This is, I work for my own rejuvenation and my longevity, and I'm pleased to see that it seems to be working. But again, this video is to give you some idea how our vascular system works, why it is important. And I refer to many publications. There are even more publications which I didn't present here, but again, it is very established area of research that our age actually is related to vascular aging, vascular stiffness. Okay, let's go in for the details. Here I present my point of view on aging and useful markers of aging that can be used to estimate the effectiveness of changes in our diet, lifestyle, supplements, treatments, and physical activities for health and lifespan extension. Instead of measuring the average cellular age of our bodies with a so-called epigenetic clock, which measures the level of methylation in DNA in tissues, I propose to use a blood pressure monitor to estimate your whole body biological age. It is known that blood pressure and resting heartbeat rate change with age due to the increased stiffness of our blood vessels, also increased vascular resistance, so it is resistance to flow of blood, and these which are a hallmark of the whole body aging. Moreover, hypertension is related to the risk of cardiovascular diseases, which are the main cause of death in the elderly. So what I recommend, buy a simple blood pressure monitor. Use it. It's in Thailand. I got my blood pressure monitor just for below $10 American, and I use it for years. It is easy and cheap. So I can do measurements every day, and I do it quite often to see the impact of some dietary changes and impact of the exercises. So it works. So let's go. What is aging in humans and how we can measure it? According to publications, this number one, and pardon, aging involves a gradual loss of physiological integrity, leading to impaired function and increased vulnerability to death. The publication, this following publication, this number one publication suggests four primary hallmarks of aging. It is genome stability, telomere shortening, epigenetic methylation alteration, and loss of proteostasis. And also five secondary hallmarks. It is deregulated nutrient sensing, mitochondrial dysfunction, cellular senescence, stem cells exhaustion, and altered intercellular communication. Recently, three more hallmarks were added to make the picture even more complicated. So it's actually, again, it's whatever. This includes disabled macroautophagy, macroautophagy, and disabled also mitophagy, chronic inflammation, dysbiosis. Yeah, so you can read the publication. However, this list does not represent the root causes of aging, and it causes confusion among researchers. So you can read it. It is actually, there is no clear understanding what is aging, what is the root cause of aging, and I have my own opinion, and it's very much different from what we presented in this publication. This is an opinion of the people. People mostly relate the aging to the age of cells, to cells. I mean, if cells are age, they believe that we are aging because cells are aging, but it is not true. Our body consists of frame, which is extracellular matrix, frame of collagen and elastin fibers, and cells are just supported by this frame, and they can be replaced by stem cells. And this, as we develop from one singular stem cell, singular cell, we can produce any organs actually, at least in a theory, any organs and replace any damaged organ, and we can live forever. This is how it should be. Okay. So again, my opinion on aging is different, and it is not the same what is dominated opinion. And the root cause of aging is stiffening of all tissues, especially blood vessels, due to the destruction of elastin fibers, replacement of them with 10 or 1000 times stiffer collagen fibers. Stiffness depends on the type of collagen. Stiffening of collagen fibers due to cross-linking of the fibers by sugar molecules, and eventually calcification of blood vessels and even of some tissues. Another important factor of aging is accumulation of waste products, toxins, misfolded proteins, lipofuscin, oxidated polyunsaturated fatty acids, and lipoproteins inside and outside our cells. I would say that didn't mention here, but it is important accumulation of oxalates, salts of oxalic acid. This is very big toxin. So it is I related to toxin, and removing of this oxalate is very difficult, and it is actually contribute to stiffening of our tissues and to damage our tissues. Okay, stiffening of blood vessels results in compromised oxygen delivery to tissues, which is named hypoxia, and oxidative stress. Oxidative stress, it is the next process, and why it happens? Because of excessive production of free radicals that are reactive oxygen species by definition, and they are produced by mitochondria in conditions of hypoxia. Excessive production of reactive oxygen species may damage cellular membranes and DNA and lead to apoptosis or death of the cells. So, what is happening with arteria? Maybe this slide I will show again later. So, what is happening? Normal arteria is elastic. It has a lot of elastin fibers, but in time we have deposition of collagen inside, and thickness of the cell is growing, stiffening. It is also getting stiff. So, and then this is how arterial stiffness develop. So, to protect themselves from oxidative stress and apoptosis because of hypoxia, cells shift from production of energy by mitochondria to glycolysis, which is a process of energy production in cytoplasm without oxygen. So, you say you don't supply enough oxygen, cells to survive, they try to produce energy by glycolysis. Production of energy by glycolysis is typical for tumor cells, which are, again, cancer cells. They try to survive and in conditions of low hypoxia, and this is known as a Warburg effect. So lactate that is produced from glucose in the glycolysis process acidifies the intra and extracellular microenvironment. In particular, tumor microenvironment tend to be acidic due to increased metabolic activity, poor blood supply, and hypoxia, and the accumulation of metabolic byproducts such as lactate. Also, in condition of hypoxia and acidic environment, so acidosis, some healthy cells become senescent and produce pro-inflammatory signal molecules that are called the senescent-associated secretory phenotype. So it is normal reaction of cells to damage and to hypoxia to try to give some signals and to produce inflammation. Inflammation, it's actually inflammation. It is like swelling of the tissues and improvement of the blood supply to locally. So it is normal process of wound healing and tissue repair, but in age, as we are aging, it works not so productive. It's actually this make us mortal, and we die. So this is how it normally goes. So mostly cells produce energy by oxidation in the mitochondria. It has name oxidative phosphorylation, and only few percent probably by in cytoplasm converting glucose to pyruvate and lactate, and but cancer cells and any malignant cells, also senescent cells and cells infected by viruses, they use glucose and they produce pyruvate. Pyruvate mostly goes to produce lactate here, but about 5% maybe go to, if oxygen is available, go to mitochondria to produce a little bit of energy, extra energy with this. But again, it depends. It is in case of hypoxia, but another reason, even if oxygen is available, this highly active cells, these malignant cells, they need they produce proteins, and for to cancer tumors have to grow, they need production of proteins, so they save a little bit, they save nutrients, not burning them to CO2 and water, but they use these nutrients to produce more proteins. And also senescent cells produces pro-inflammatory signal molecules, which are kind of protein molecules. Okay, so it's again, you can see what is happening in case of acidosis. It is just what you have when people are getting older. It is all the symptoms of acidosis. This is what you have. So the signal molecules, this SASP, ignite the production of collagen by fibroblasts and the transition of other healthy cells into the state of senescence to increase the production of these signal molecules and attract immune stem cells. This is normal process of wound healing. In young body, it is normal that wound healing goes this way, and but again, in aging, it's already destructive. Immune cells are supposed to engulf and destroy malignant senescent cells and cancer cells, as well as excess collagen, and break it to amino acids and other nutrients. And the nutrients produced by the immune cells are supposed to be used by stem cells to rebuild the damaged tissue. This is a normal process of the wound healing and tissue damage. The repair of the tissue damage. But however, the state of acidosis can suppress the activity of various immune cells, including T lymphocytes and natural killer cells. These cells play a crucial role in decognizing and eliminating malignant cells. So it is again, you can say tumor protect itself by this acidosis, by local acidity. But cancer cells, senescent cells will do the same. So if you have many senescent cells, they actually protect themselves, and they grow in numbers. Also, acidosis can impede the migration of immune cells to the inflamed tissue and tumor sites. This is again the mechanism of aging. Acidosis may promote the generation of immunosuppressive cells, such as myeloid-derived suppressor cells and regulatory T cells. These cells can dampen the immune response and create an environment that benefits survival of these malignant cells. This is again normal process, but you have to understand why it develops. It develops because of the hypoxia, chronic hypoxia, and the compromised blood flow. And if it is just a wound, and if it is local, it can be repaired. But when in aging, it is already stiffening of all our body, then you have this chronic inflammation, and then aging and eventually death. In time, due to accumulation of senescent cells, chronic inflammation of tissue develops that lead to fibrosis of tissues due to overproduction of collagen fibers by fibroblasts, and ultimately to death of the limbs. This is what I was talking about. This is normal process of wound healing when it is going related to age, when all tissues get in conditions of chronic hypoxia. This is what we are getting. The number of these senescent cells grows uncontrollably, and it leads to chronic inflammation and eventually to death. We have to consider an increase in the vascular resistance of small blood vessels and capillaries to blood flow due to damage to a layer of endothelium that lines the inside of the blood vessel. I was talking about this a lot, but again, what is normal in age, that this endothelium layer is damaged, and it cannot get dilation. And also it is the process of endothelium controls vasodilation and the growth of new blood vessels, or so-called angiogenesis, to improve blood flow in the tissue. If it is damaged, then it is again, you have compromised blood flow, and new blood vessels don't grow. So you see, it's all the markers of aging. So I propose to use blood pressure monitor to estimate our biological age, which is related to the elasticity of blood vessels and peripheral vascular resistance of blood flow. Okay, you see the two, two factors. Elasticity of blood vessels, especially aorta and arteries, important, yeah, because they help to provide to keep this flow of blood steady, a little bit more steady. And vascular resistance to the blood flow. If to push blood through narrow blood vessels is difficult. So it is again in age, if this vascular, if in case of this damage to endothelium, we cannot have vasodilation, so we cannot get wider capillaries and blood vessels. So it is again, it is growing. The resistance is growing. So, but we can calculate it. We can see it by measurements of the blood pressure. Such characteristics like systolic and diastolic blood pressure, mean blood pressure, and pulse pressure correlate with biological age of humans. This is again, this is a marker of aging. So if it correlates, let's use it. So simple and affordable measurements can help us to decide about the efficiency of supplements and treatments, physical activity, lifestyle changes, diets, in slowing the rate of aging, extending our lifespan. Let's go deeper into the understanding what a blood pressure monitor is measures and how it is linked to aging. Okay, so this is what I was talking. There is a publication which relates age. Of course, it is statistical age in some big groups, and this was done. These measurements were done long ago, when not many medications were used, and they were again done with people who didn't use medication. So we can see that that chronological age relates to pulse pressure, a very sharp increase of pulse pressure in some people indicates that they are aging, and we see diastolic pressure, diastolic pressure behavior, systolic pressure behavior with age. But again, the pulse pressure seems to be the most reliable marker of aging. So the big arteries contain elastic fibers, mainly made up to elastin 90% and fibrillin-rich microfibrils 10%. Providing them is elasticity. Again, arteries and aorta, they need elasticity. Elasticity of the aorta and crucial during the heart pumping action. When the heart contracts, this is systole, the aorta stores energy and blood from the heart contraction. In the relaxation phase, diastole of the cardiac cycle, this stored energy and blood is released, aiding to smoother blood flow in the arteries and our arterioles, which are the smaller blood vessels between artery and capillaries. So the heart generates in elastic arteries a pressure wave during the contraction, and then this wave is traveling through the vessel, through the aorta and arteries at slower speed. As wave travels, it encounters different resistance levels along the vessel walls, leading some of it to reflect back to the heart. So why it is happening? You see what aorta is very big vessel and very actually thick. So when this elastic pulse pressure wave go down, then it is reflected from this place and go down. And what is happening? It is like first it is the heart is pumping blood, aorta is getting wider, it accumulates the blood and pressure, and then because of elasticity of the aorta, it is pushing blood along this our circulation system. Okay, so pardon, what is happening? Okay, the big arteries. Okay, sorry. So this again, the mostly if we look aorta has this ascending aorta, and this area also descending aorta is the thoracic part of the aorta. They are most elastic. They are most important. This area is less elastic. And then this it is also work in to smoothing the blood pressure variations, but again, this is the most important part of our our blood circulation system. What is happening again? we check in young person. During the systole, during the contraction of the heart, blood go to aorta, and aorta getting thicker. I mean, it widens, it dilates, and then during diastole, when heart is relaxed, what is happening? This blood which is accumulated inside the aorta, it's going down. It is pressed due to elasticity of aorta. It just go down further to the blood vessels. But in old aorta, and things are different. First, aorta is getting much bigger in size. Thickness of the walls also getting bigger. And what is happening? And the heart is pumping blood inside, but during the relaxation, during the diastole stage, it is just stopped to pumping, so pressure drops, and actually only in stage of systolic stage, pressure blood go down, but this is stage doesn't work. So it is more it's what is happening. The size of the heart is increasing because it has to provide blood, and it is try to keep us alive. Okay, so when it is reflected from, as I said, from this area, it is reflected. This reflection combined to create backward traveling, so-called reflected wave, returning to the heart during late systole and early diastole. This reflected wave enhances diastolic filling pressure in the aorta, improving coronary flow and contributing to more forceful contraction in the next cardiac cycle. So, okay, I mean, this is, helpful because, and also it is smoothing the flow of blood. However, as people age, the aorta undergoes changes like stiffening, dilating, and thickening of the aorta wall, due to factors such as intimal wall thickening, elastin fragmentation, and excessive collagen deposition. You can read this article. This is very well established scientific fact about the change of the aorta. And these changes are increasing arterial stiffness and systolic blood pressure in the central arteries, decreasing diastolic pressure decreasing diastolic pressure, reducing blood flow to the coronary arteries, and shortening the duration of the diastolic filling in the cardiac cycle. So again, so you see here, again, we see the diastolic pressure after age of like 55. It is starting to drop, because of higher stiffness of the aorta. But systolic pressure continues to grow. Systolic pressure continues to grow, and pulse pressure also continues to grow as we are aging. In average, of course. So again, so what? How to measure? You know, normally systolic, diastolic blood pressures are usually measured at the upper arm artery. Okay, so I don't have picture, but okay, you understand it. So what we have the definition. That's the oscillations of blood pressure in aorta and elastic arteries and muscular arteries, and then we have systolic blood pressure, local measured, and diastolic blood pressure locally measured. We have pulse pressure, which is difference between systolic and diastolic, and we have mean arterial pressure also. But okay, you see how it is changing further. So as blood is going to smaller and smaller blood vessels and eventually capillaries, the blood pressure of course dropping. So this is how it works, and we go further this definitions. And systemic blood pressure is the difference between systolic blood pressure and diastolic blood pressure. Plus pulse pressure is inversely proportional to elasticity of the aorta, with a healthy range in young adults between 30 and 40 millimeters per millimeters of mercury. Okay, so again, we can jump to these plots, pulse pressure, you see, and it is difference between systolic and diastolic pressure, and because of this how the systolic and diastolic pressure behave, we have sharp increase in pulse pressure after age like 50 and further. Okay, So what we have also we have vascular resistance. So mean arterial pressure is average blood pressure, which is used to measure vascular resistance, because to push blood through all the capillaries and blood vessels, you need some pressure. So it can be used as measurement of vascular resistance, at least for a while, at least in some not very old age. And but in conditions that cardiac output remains constant. So if you go to exercises, of course, the mean arterial pressure goes up, but yet it is some indication. If we know cardiac output, it is some indication of vascular resistance. So cardiac output is determined by the resting heartbeat rate and stroke volume of the heart. The big heart makes a big cardiac output, and also if a heart is big and strong, it is the resting heart rate is slow. Well, and then what? Stroke volume, and it can and this cardiac output. It can increase during exercise or stress. Sure, heart is pumping blood and provide oxygen and nutrients to muscles, and or in case of stress, it's also keep our body active. While decreased with age, decreased cardiac output may indicate heart failure. What is indication again of the decreased cardiac output? It is high resting heart rate. So it is slow, then we estimate that, okay, that cardiac output is big, our heart is big and it is pumping blood efficiently, but with age heart is getting weak, and then the cardiac output is also dropping. So vascular resistance, it is important again to push all the blood through the capillaries, and it includes peripheral vascular resistance in the lungs and systemic vascular resistance in the body. So it is again blood goes two ways, to lungs and to body, and we can separate resistance here and there. And systemic vascular resistance is influenced by blood vessels diameter. And also vascular compliance. Vascular compliance, it is actually elasticity of the blood vessels, and to a lesser extent changes in blood viscosity. Vascular compliance is determined by the muscle tone in the smooth muscle tissue, in the it is actually elasticity of the elastic fibers there. Widening or vasodilation of the vessels decreases this vascular resistance, systemic vascular resistance, while if it is getting smaller, if we go to vasoconstriction, the resistance, systemic vascular resistance is increasing. It's obvious, okay? So you have to increase size of the blood vessels to reduce resistance, to improve the blood flow. Vasoconstriction and vasodilation can be triggered by external factors such as exposure to cold and hot environment and aerobic exercise. So this is why I recommended to go take some hot baths or cold shower or this icy water bath, but aerobic exercises work even better. Under normal conditions, nitric oxide produced by endothelium cells regulate vasodilation, influencing blood flow. Okay, you can go. This endothelium cells, endothelium layer is very, very important, and it can be destroyed. And what we also, I discussed it about the role also the glycocalyx, which is protecting layer on the endothelium cells. And glycocalyx can be damaged, and then the ability of this endothelium cells to produce nitric oxide is compromised. So histamine, when you have some damage of the tissue by wounds or by infection, then histamine will be released by mast cells and basophils, and it triggers inflammation. Vasodilation and increased blood flow in response to damage, allergens, and infection. Yes, okay, so inflammation can help to provide better blood flow, but if it is chronic inflammation, it is already doesn't work. Okay, what else? Inflammation also triggers angiogenesis, the growth of new capillaries, and we can say that this growth of new capillaries stimulated by hypoxia and compromised blood flow, but not the chronic hypoxia. Chronic hypoxia will not have, but intermittent hypoxia, like due to high intensity interval training, it helps to grow new capillaries, and it helps to reduce vascular resistance. It helps to provide better blood flow, so you can try to do it. So to enhance blood flow in tissues. Okay, this is vasodilation, vasoconstriction. So it's schematically shown that vasodilation helps to provide better blood flow. As people age, decreased nitric oxide production, blood vessel stiffening, and reduced capillary flow contribute to changes in the blood pressure. The systolic blood pressure and mean arterial pressure increase with age, while diastolic blood pressure decreases after age of 50. So it's, again, you can read this and other publications. This is very established fact. Measuring arterial stiffness through pulse wave velocity remains an important technique to study aging, but unfortunately it is not so easy to buy such monitor to measure pulse wave velocity. It's also not reliable. And pulse wave velocity is the speed at which blood pressure pulse travels through the circulatory system, typically in artery, and it tends to increase with age following the increase in arterial stiffness over time, especially after 50 years of age in hypertensive patients. Okay, maintaining low aortic stiffness from early age may protect against diseases later in life. However, pulse wave velocity by itself is hardly a close correlate to of individuals' physiological age of life expectancy. So even if I appreciate such a method to measure elasticity of aorta and arteries, then it is not reliable. Pulse pressure is better. Increased vascular stiffness is often linked to the progression of atherosclerosis and conditions impacting the arterial wall through the endothelium dysfunction, vascular remodeling, and elastin breakdown. So you can read these factors and scientific publications about the role of these processes. Endothelium function is very important, even in large arteries. Because endothelium layer protects the wall of aorta and arteria, so it has to be healthy. So this association is observed in humans and supported by limited animal studies. So okay, again, new publication, a lot of hundreds publication on this area. It's very well established fact. So why the stiffening is develops and how it is related to endothelium dysfunction and all this stiffening of the extracellular matrix. Arterial stiffness is considered both a cause and consequence of atherosclerosis, and its progression can lead to the increase in pulse pressure, contributing to cardiovascular disease. Okay, then again, I have some videos on atherosclerosis, what to do with it, why it develops, so I don't give this answer, but okay, just to give you some understanding about science behind these measurements. Arterial stiffness is suggested as a useful marker for assessing the presence of atherosclerosis, and it is influenced by factors like age and hypertension. An age-related factor for increased vascular stiffness is stiffening of the extracellular matrix due to cross-linking of the extracellular matrix proteins, especially proteins. What kind of proteins? Elastin and collagen, both. And excessive collagen production and calcification. You go to the publication again. It is very common knowledge. What is happening with elastic arteries? Again, you see that elastic aorta is widening, is dilates and keeps blood and pressure, and then it is pushing blood during diastolic stage and diastole, and then it works good. During diastole, it is pushing blood flow and keeps blood flow steady without large oscillations of pressure. But in stiff arteries, in old arteries, it is different. It is again blood pumps, I mean heart pumps blood, but it's only during the systolic age stage. In a stage of diastole, its blood is just almost don't go. Also, not a direct measure of arterial stiffness, pulse pressure have been used as a surrogate marker of vascular health, aortic stiffness, and vascular compliance. Easily measurable with a standard blood pressure monitor, pulse pressure serves as a straightforward indication of arterial stiffness in clinical practice. Okay, so you see that we can, it is related, pulse pressure related to stiffness, and I claim that stiffness of the arterial wall and stiffness of aorta is our vascular age, in the marker of vascular age. However, major gaps still exist in our understanding of the relationship between pulse pressure and aortic stiffness. Okay, so again, in general, we more or less understand, but there are some yet details to understand. Okay, that's again, our body is not is quite complicated, and many factors are involved. Numerous studies support its relevance in predicting cardiovascular risk and as a surrogate marker for arterial compliance. So it is elasticity of arterial walls. It is interesting that there is a correlation between endothelium function and the production of nitric oxide to dilate blood vessels. Okay, then it's interesting again that the results in the in vivo study demonstrate that large artery stiffness and central hemodynamics are influenced by endothelium function. Again, if you have healthy endothelium, then it is also produce nitric oxide. But it is interesting, if it is endothelium layer is healthy, it protects the wall, and wall is yet stay elastic for longer. Otherwise, it will be swollen. There will be inflammation in the wall of the artery or aorta, and then it will contribute to stiffness because of this excessive production of collagen, etc. And so it is again, we have to protect our blood vessels, and endothelium layer is very, very much important, and production of nitric oxide in smaller vessels helps to reduce vascular resistance. Again, we have this plots pulse, which I believe the best indication of best marker of our aging. So if you see, it is of course average, and it is for people who didn't do anything special, any intervention to reduce age rate of aging. So you can see, but you can estimate your biological age if you have some blood pressure like this or this. Okay, so you can do it. It has long been known that lifespan is inversely related to resting heartbeat rate in most organisms. It is interesting that resting heart rate is inversely related to arterial stiffness. Okay, it's also understandable because you have very elastic aorta, then aorta helps to push blood through your blood circulation system, and it is actually less stress to heart. So it's then resting heartbeat rate is reduced, and also if with slow heart rate, it is reduce rate of aging. A high resting heart rate was associated with increased risk of death and cardiovascular events in men between 50 and 60 years old. Men in their 50s who have a resting heartbeat rate 75 beats per minute or higher are twice likely to die from heart disease within 11 years. So in contrast to peers with a resting heartbeat rate is only 55 beats per minute or fewer. What's more, every additional beat increase in resting heartbeat rate was associated with 3% higher risk of death from any cause. and 1% higher risk of cardiovascular disease, and 2% higher risk of coronary heart disease. So you see, it's if your heart is working slowly, everything is good. Then you have a good elasticity of blood vessels, you have a strong and healthy heart, so it helps to live longer. So we have this for animals, some plot which relates heartbeat rate to life expectancy, and humans are a little bit special. But again, this I would believe that humans were created from apes and from apes to live forever, and we have the mechanism to live forever. But now we live only 70 and 80 years maximum. In Hong Kong, 86, I believe, average life expectancy. So, and why again, why we live so short? It is two factors, to my opinion. It is breeding with Neanderthals, which are apes actually, and apes live not so long. So breeding and breeding with them and mixing with them make humans living shorter. But this we can suppress epigenetically. We can suppress these bad genes for Neanderthals with epigenetic measures, like with diet and some supplements, and also lifestyle. But yet again, food is also important, because again, take Hong Kong. Hong Kong is 86 average lifespan expectancy, but in other countries it is maybe 72, 75. So, and it is like in 65, 67, you go to retire and you have like free time, 10 years to enjoy life, but you don't enjoy it because you have pain, you have all these problems with your body and inflammation. So it is actually, yeah, it's suffering. No, it's not. It's not resting. It is just, yeah, it's disaster. Okay. All known studies reveal that in healthy people and patients with certain illnesses, lower resting heartbeat rate values provide greater longevity. Okay. So in all people, the low heartbeat rate is better. High resting heartbeat rate is related to decreased physical fitness, increased blood pressure, increased body weight, and higher levels of circulating free triglycerides in the blood. So partaking in aerobic exercise, which is the most important and most the efficient way to reduce heartbeat rate and to improve elasticity of your blood vessels, by the way. So it's a very important factor. So like, and what can be aerobic exercise? Running, jogging, swimming, cycling, and triathlon, and the best way to improve your blood circulation system and extend your life span. So it's also a reliable method to reduce resting heartbeat rate. So for those in excellent health and who engage in intense physical activity, resting heartbeat rate might be even go down to range of 40 to 50. Some world champion triathletes, swimmers and cyclists had a resting heartbeat rate from 33 to 38. This is again, I never had so low. So I was certainly not world champion, but I was good, well trained, and my heartbeat rate was about 40, 42, let's say, in young age. It's now also not bad. While low resting heartbeat rate is generally beneficial, researchers are still studying the specifics of its relationship with longevity, particularly in men over 50. Okay, so what we have, that heartbeat rate, it is in age, heartbeat rate in beats, and mortality. So you have below 50, its mortality is dropped, and it is two times higher mortality if you have heartbeat rate 80 more than 90. So it's okay. Also, this is just some data about that's measurements in many men and women, and then what is also helping to see that heartbeat rate average heartbeat rate, and what we have body mass index, etc. So, and I invite you to go to these references and learn this subject is in more details. It is very many references, I would say, and develop your own opinion, because again, science, there is no established science. There are opinions, and dominating opinion is not always true, and I would say mostly it is not true, because any sort of human activity is business, including science. Everybody want to try money, want to produce money from life, because we need to earn money to. But how to do it? And medical professionals do it in their own way, and I do it in own way. So it's again, there is no pure science. There is no ideal science. Science is corrupted because now sciences became a part of propaganda. And trust me, a society is not not interested to extend your lifespan beyond like 75 years. It's because otherwise, if you will live 175 years, imagine how much money society has to pay you for retirement. Yeah, it's incredible. So nobody can afford it. So this, I have some proposals what to do with it and how to escape this trap. But okay, but now again, now I am interested in my own rejuvenation and to extend in my lifespan. And if I will look this plot and can estimate I'm age of 66 and I'm supposed to be somewhere in this range, and minimum pardon, minimum pulse pressure should be in my age like 55, maybe 55, 50, 55 pulse rate, pulse pressure 55, but I have 35, and 35 is in this range, so it's probably it relates to 45. So I'm like in my vascular age. It is not all organs, not appearance, but vascular age is maybe 20 years younger. Maybe I am 20 years younger, but again, I got it not overnight. It is years of hard work and exercises and special diet and supplements. So it's not easy, but it is worthwhile to do to get rejuvenation, because again, you have your full energy, you can do whatever, you can earn money actually, even in old age with all this computer system and internet. So yeah, I recommend to, and again, it's so cheap. Yeah, just make it instead of paying large money for so-called dominant opinion, dominant way to evaluate your age with so-called epigenetic clock, which is nonsense, I believe. But again, it's not my opinion, which is much different from dominating opinion. Okay. So, what else I want to remind you that I'm not medical professional. I'm doctor in physics, and I'm professional scientist. So I never trust anybody opinion unless it is supported by results of experiment and the results of measurements. So to my opinion, I try to not confuse myself. I work for my own rejuvenation. So I'm pleased to see and that it seems to be working, even slowly, but it works. And then, so I'm share this information and hope that it will be for you also interesting, and you will do all the research. You will get your opinion. Will coincide opinion? Your opinion will coincide with mine or with official recommendation. I don't know. It's again, you can do it. You can do science. Okay, I hope you enjoyed this video and learned something new. And again, if you like it, at least what you can do, you can press the like and bell button, subscribe to my channel, share this video with your friends and family. And this is important for me because I'm not getting any money from YouTube, not getting any official support. Unfortunately, I have only a little bit more than 1,000 subscribers. It is, I would expect it would be millions, but I should say that I never tried to get many subscribers to my channel. I do it for myself. My primary goal is my own rejuvenation, my own health. So I don't care much because I don't get any money. But if you can think that you are interested to do this research together, then we can do it. We can organize this our cooperation and do it together. So whatever. So have a wonderful day. I wish you good health and long life. Bye, ciao, ciao.